Hello friends, in this video lecture I shall explain very basic concepts of central limit theorem. Even if you are normal, the average norm. The question is how? The central limit theorem clearly explains. To make any sense at all, you should be familiar with the normal distribution, and if it would also be helpful if you were familiar with the concept of sampling from sampling distribution. The central limit theorem is the basis for a lot of statistics, and good news is that it is a pretty concept. I will explain what central limit theorem is and why it is important for statistical inference. Like most things in statistics, I think the central limit theorem is easiest to understand if we look at some examples. So let's start with a uniform distribution. The probabilities are all equal and thus are uniform. And then calculate the mean of the samples. We can collect 20 random samples from this uniform distribution. On the right, we can draw a histogram of the mean value. Since we only have one mean value, the histogram isn't very interesting. The histogram starts to look at little more interesting. But after we collect 10 more samples and calculate 10 more means for 20 means, for 30 means, 40 means, and so on, 80 means, 90 means, 100 means. After adding 100 means to the histogram, it's pretty easy to see that these means are normally distributed. Means are normally distributed. I did this because this is what the central limit theorem is all about. We have started with the uniform distribution. Even though these means were calculated using data from a uniform distribution, the means themselves are not uniformly distributed. Instead, the means are normally distributed. Another example. This time we will start with an exponential distribution. Just like before, we can collect 20 random samples from this exponential distribution, and just like before, we can calculate the mean of 20 samples. After we collect 10 samples and calculate 10 means, the histogram starts to look a little more interesting. For 20 means, the histogram look like this. For 30 means, for 40 means, and so on for 100 means. After adding 100 means to the histogram, we can see that they are normally distributed. Even though these means were calculated using data from an exponential distribution, the means themselves are not exponentially distributed. Instead, the means are normally distributed. So far, we have seen that means calculated from samples taken from a uniform distribution are normally distributed, and means calculated from samples taken from an exponential distribution are also normally distributed. Well, it turns out that it doesn't matter what distribution you start with. If you collect sample from those distribution, the means will be normally distributed. But what the practical implications of knowing that means are normally distributed? When we do an experiment, we don't always know what distribution our data comes from. To this, the central limit theorem says, who cares? The sample means will be normally distributed because we know that sample means are normally distributed, we don't need to worry too much about the distribution that the samples came from. We can use the means normal distribution to make confidence interval, do t-tests when we ask if there is a difference between the means from two samples, and ANOVA where we ask if there is a difference among the means from three or more, and pretty much that uses the sample means. Out there in the wild, some folks say that in order for the CLT to be true, the sample size must be at least 30. This is just a rule or thumb and generally considered safe. However, as you can see in this examples, here we here where I use a sample size of 20, the rules was meant to be broken. Here is the fine print. In order for the CLT to work at all, you have to be able to calculate a mean from your sample. Off the top of my head, I can only think of one distribution, that is Cauchy distribution, that doesn't have a sample mean. This is all about the basic concept of central limit theorem. Thank you.